This is 10.1, Reading Graphs and the Rectangular Coordinate System. The Cartesian coordinate system was developed by a French mathematician, René Descartes. The system connected algebraic equations with points on geometric graphs. The system starts with drawing the intersection of two number lines that are perpendicular to each other. The two number lines are called the x-axis, which is the horizontal number line, and the y-axis, which is the vertical number line. And then the point where they meet is the origin. This divides our graph up into four boxes or four parts, and those are called quadrants. Those quadrants are numbered using only Roman numerals, and they go counterclockwise, starting with the upper right box. An ordered pair is the same thing as a point, and it shows the location in the Cartesian coordinate system. And once we locate a specific point, we use a capital letter to name that point. So the coordinates, or the ordered pair, shows how far we go left and right, which is on the x-axis, and how far we go up and down, which is on the y-axis. So we always label a point or with an ordered pair, which is two numbers, the direction left and right and up and down. A graph is a picture representation of an equation, and when you're told to graph something, that just means to draw a picture of the equation. So this is what the Cartesian coordinate system would look like, and this would be our x-axis, and this is our y-axis. All right, this is x, and this is the y-axis. And then this point right here, where they meet, that's called the origin. And then, like I said, these four boxes that it's divided up into, those are called quadrants. So this would be quadrant 1, and then we go counterclockwise, quadrant 2, quadrant 3, and quadrant 4. And an ordered pair would have some numbers like 2, 5, and that would tell us how far we go. We would go 2 spaces on the number line, on the x number line, and then 5 spaces up to plot our point. So then this is the x coordinate, and this is the y coordinate. So now we're going to plot each ordered pair on the graph below. We always start with, whenever we're graphing points, we always start at the origin, at the center of our graph. And then we go left or right. If it's positive, we're going to go to the right. If it's negative, we're going to go to the left. And then we go up or down. Again, if it's positive, we're going to go up. If it's negative, we would go down. So this first point that we're going to plot is 5, 3. We start at the origin, and the coordinates of the origin are 0, 0. All right, so if we're at 0, 0, if we go 5, 3, we're going to go to the right 1, 2, 3, 4, 5, and then we go up 3, 1, 2, 3. So that would be point A. All right, and then for B, it's 8, 0. So again, we start at 0, 0 at the origin, and we go 8, 1, 2, 3, 4, 5, 6, 7, 8, and then our y coordinate is 0, which means we don't go anywhere on the y. We stay on the axis. So that would be point B. Okay, for point C, it's -2, -1. So if we start at 0, 0, -2 would be to the left 1, 2 spaces, and then -1 would go down 1. So that's C. Then D is -1, -2. All right, so we go -1, -1, 2. So that is point D. All right, the next point is 0, 3. So if we start here at the origin and we go 0 spaces on our x-axis, that means we don't go left or right. And then the y-coordinate is 3, so we just go up 1, 2, 3 on the y-axis. And that is E. All right, F is 3, negative 3, positive 3, negative 3. So we're going to go to the right, 1, 2, 3, and then negative 3 would be down, 1, 2, 3. So that's F. All right, G is 0 and then negative 5.5. All right, let me move this down a little bit. 0, negative 5.5. Okay, so 0 means we don't go left or right, but then negative 5.5, we would go down 1, 2, 3, 4, 5, and then halfway to the next point. So we can have points on our graph that are not whole numbers. All right, so that was G. All right, and then H is 0, 0. Well, 0, 0 is our origin, so we don't go anywhere. 0, 0 is right here in the middle, and that is H. All right, for I, we have 3 over 2. Anytime we have an improper fraction, if we're trying to graph that point, it's best to change it into a mixed number. So if you'll remember, the way that we change a fraction into a mixed number is we take the numerator, divide it by the denominator. So 2 will go into 3 one whole time with 1 left over, and we put that 1 over what we were dividing by. So 3 over 2 is the same as 1.5. Let me rewrite that. Ooh. All right, 1.5. Because 1.5, that's easier to see where it is on the graph than 3/2. Okay, so 1.5, 2. So we go to the right 1.5 and then up 2. So we got to stay in between the points and go up 1, 2. So that would be my point I. And then J is negative 5, 2. So we're going to go to the left 1, 2, 3, 4, 5. And then positive 2 would be up 2. So that's point J. And that's how we plot points on the Cartesian coordinate system. Now we're going to look at the points and tell what their coordinates are. So for A, we have A right here. Remember, we start at 0, 0, and we do left and right first, and we have to stay on the lines to get to our point. Okay, so we can't cut across the grass. We have to stay on the roads. So to get to A, we're going to go to the left 1, 2, 3. So since we're going to the left, that's a negative 3. And then we go up 1, 2, 3. So that's positive 3. Now, anytime you write an ordered pair, you have to put it in parentheses. All right, for B, there's point B. If we start at 0, 0 and we follow the lines, we're going to go to the right 1, 2, 3, 4, 5 spaces. So since we went to the right, that's a positive 5. And then we're going to go up 1, 2, 3, 4. So again, that's a positive since we went up 4 and put it in parentheses. Okay, for C, C is over here. If we start at 0, 0, we're going to the left, which is negative 1, 2, 3, 4, 5. All right, so a negative 5. And then we go down 1, so that's a negative 1. For D, if we start at 0, 0, our x is first, left and right is first. Well, we don't go left or right. So that means my x coordinate is 0. and then we go down one space, which is -1. For E, we're going to go to the right 1, 2, 3. That's a +3. And then we don't go up or down, so my y-coordinate is 0. Okay, and then the last one, F, we're going to go to the right 1, 2, 3, 4, 5 spaces. So that's a +5, and down 1, 2. -2. So +5, -2. All right, an ordered pair is a solution of an equation if the values result in a true statement. So we can determine if an ordered pair is a solution to an equation by plugging the ordered pair into the equation and seeing if it comes out to be a true statement. So we're going to determine which of the given ordered pairs satisfies this equation, 3x plus 4y equals 10. Well, remember, in our ordered pair, the first value is my x coordinate and the second one is my y. So that means we're going to plug -2 in for x and 3 in for y. All right, so 3, we're plugging in -2 for x plus 4 times 3 for y. And then we want to simplify this and see if it's a true statement. 3 times -2, that would be -6. 4 times 3 is 12. -6 plus 12 would be 6, and 6 does not equal 10. So this is not a solution. All right, let's try B. Okay, so we're going to plug in 0 for x and 2.5 for y. Well, 3 times 0 is 0, and then 4 times 2.5 would be 10. So we get 10 equals 10. So this would be a solution because it's true. All right. For C, we're going to plug in 4 for x and -2 for y. 3 times 4 is 12, and 4 times -2 would be -8. Well, 12 plus -8, or 12 minus 8, would be 4. And 4 does not equal 10. Put that here too. So this is not a solution. All right, let's try this last one. We're going to plug in 1.2 for x and 1.6 for y. All right, so let me come over here to the side to multiply these decimals. Okay, so if I'm going to multiply 3 times 1.2, 3 times 2 is 6, and 3 times 1 is 3, so that's 3.6. And then if I multiply 4 times 1.6, that's 6 times 4 is 24, and then 4 times 1 is 4, plus 2 would be 6. All right, and then if we add these two together, 3.6 plus 6.4, move this down a little bit, that 6 plus 4 is 10, and then we get 6 plus 3 plus 1 would be 10. So 10.0 is the same as 10. So we get 10 equals 10. So this is a solution. So both of these were solutions to this equation because it came out to be true. The ones that were not true were not solutions to the equation. All right, so now we're going to graph some linear equations by setting up t-tables. In algebra, we don't just plot points to connect the dots to make pretty pictures. We plot the points to form graphs of equations. Because we've learned about linear equations in Math 98, our graphs will all be pictures of lines. Linear equation means lines. So in order to draw a line, you have to have at least 2 points to plot. When we're given an equation, in order to get the points that go with that equation, we can set up a t-table. Well, in these examples, the t-table is already drawn for us. The reason why it's called a t-table, these are actual tables, but if you were going to draw a t-table yourself, a lot of times it would just look like this. So we would have, and we would put our x here and our y here, but see, this looks like a t. So that's why it's called a t-table, in case you were wondering. And also, we can make our own t-tables. If you were just given an equation and they didn't give you a t-table like that, you could create your own t-table. And it's best, if you're creating your own t-table, to pick values like, you can pick the same values every time. You could do 0, 1, 2, or you could do 1, 2, 3, or -1, 0, 1. You want to do smaller numbers. You wouldn't want to do something really big or something. If you plugged in 10, 11, 12, well, on the x-axis, if this goes to 10, well, if you picked 10 for your x, it's not even going to be on your graph. So you want to pick stuff that's close to the center. So if I were going to make my own t-table, I would pick 0, 1, 2, or -1, 0, 1. But they have given you a t-table, and they're telling you what they want you to plug into the equation. So you have to pay attention to which coordinate it's under and plug it in for that variable to find the other missing part of the ordered pair. So each of these are going to create an ordered pair that we're going to plot on the graph. So this first one in our t-table is 0. They want us to plug in 0 for x, and we're going to find the y that goes with it. All right, so if let me make this fit a little better. Okay, so if I take this equation and I plug in 0 for x, well, 2 times 0 is just 0. So I get y equals -8. Okay, so that's what's going to go with that 0 for my x. For the next point, they want us to plug in -2 for y. Okay, so if I plug in -2 for y and solve this, I want to get the x by itself, so I'm going to add 8 to both sides of the equation. All right, and then I get 6 is equal to 2x, divide by 2, and I get 3 for x. Okay, well, they just gave me 3, so that's going to give me -2 for my y since it's the same point. Let's pick a different value. Let me just plug in 1. All right, so let's mark that out. I'm going to mark out the 3 and plug in 1. Okay, so if I plug in 1 for x, 2 times 1 is 2, and then 2 minus 6 would be a negative 4. All right, so then that would be negative 4. Now, let's plot these points on our graph. 0, negative 8. So 0 means we're not going to go left or right. We're just going to go down 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8. That's going to be at the very tip of our arrow. Okay, then 3, negative 2. 1, 2, let me see. 1, 2, 3, negative 1, 2. All right, and then 1, negative 4. So we're going to go to the right one and down 1, 2, 3, 4. So it's best if we choose 3 points, because that will help us to know if we're graphing correctly. And as I'm looking at this does not look like a straight line. So I must have done something wrong. So if we go back and check our work, I know that this is right. If I plug in 0, that goes away, so I get negative 8. Then for 3, if I plug in 3, where's the one where I plugged in 3? Well, oh, I didn't plug in 3. I plugged in negative 2. Okay, so I plugged in negative 2 for y, and added 8, got 6, bring down the 2, divide by 2, and I got 3. That one's right. Okay, here I plugged in 1. 2 times 1 is 2, but then somehow my 8 turned into a 6. So this is a good way to always, when you're graphing lines, it's a good way to check yourself by choosing 3 points, because if you just choose 2 points, any 2 points can make a line. If I have a point here and a point here, it's going to make a line, so you can't tell if you messed something up. But just like this doesn't make a line, so I know I did something wrong. So that's why when you're graphing by using a t-table, you should always pick at least 3 points when you're trying to graph the line. So now 2 minus 8, that would be a negative 6. Let's see if that makes my line work now. All right, 2, oh, let me change it here too. So this is supposed to be plugged in 1, and I got out negative 6. One, 2, 3, 4, 5, 6. Now that's going to make a straight line. Okay. So if you're doing it on paper or anything like that, it's always best to have something like you can use a driver's license, student ID, something like that to help you draw straight lines if you're doing it on paper. Okay, let's try the next equation. So we're going to plug in 0 for x first. Well, there's no such thing as a negative 0, and 0 just goes away. So we get y equals 2. Okay, now we're going to plug in 0 for y. And now we need to get the x by itself. So I'm going to subtract 2 from both sides. And that gives me negative 2 equals negative x. Well, I don't want a negative x, I want a positive x. So this is the same thing as a negative 1. So I'm going to divide both sides by negative 1, and a negative divided by negative is positive. So that would give me a positive 2 for my x value. All right, and then for the last one, if I plug in negative 3 for x, so that's negative 3 plus 2. All right, so a negative 3 would be a positive 3 plus 2, which is 5. All right, let's plot these points. 0, 2, start at 0, 0, remember, and we're not going to go left or right. We're just going to go up 2 and plot my point. And then 2, 0, we would go to the right 2, and since it's 0 for my y-coordinate, I don't go up or down. And then negative 3, 5. Negative 3 means I'm going to go to the left, 1, 2, 3. And positive 5, I'm going up, 1, 2, 3, 4, 5. And that looks like they all line up, so that tells me that my points are probably correct. All right, and we have one more to graph. In this equation, we just have y is equal to 1/3 x. My first value that we're plugging in is 0 for x, and that would be y is equal to 1/3 times 0. Well, we know anything times 0 is 0, so 0 would be my y-coordinate. Then if I plug in negative 6 for x, I have y is equal to 1/3 times negative 6. Well, since I'm multiplying times a fraction, I'm going to make this 6 a fraction by putting it over 1. Okay, so negative and positive give me a negative 6 over 3, which would reduce to negative 2. And then the last coordinate is a y-coordinate. I'm going to plug in 1 for y. And if you'll remember, the way that we can get a fraction off of a variable is we multiply by its reciprocal. So I'm going to multiply both sides by the reciprocal of 1/3, which is 3 over 1. All right, so this cancels. 3 over 1, that's really 3, times 1, which is 3. Okay, so let's plot these points. 0, 0, that's right in the center at the origin. Negative 6, negative 2, I'm going to go to the left, 1, 2, 3, 4, 5, 6, and then down 1, 2. And then 3, 1, I'm going to the right, 1, 2, 3, and up 1. And then connect my dots. And one thing I forgot to point out is anytime we're drawing a line, you should always put arrows at the ends because our line doesn't stop, and that's showing that it continues. So make sure you put arrows at the end of your line when you're graphing a line.